Hey there, everybody. All of you should have gotten one of these handouts on rational versus irrational numbers. So this, again, is there's going to be a little bit of a review. So first we started reviewing like the 4 classifications of rational numbers, and now we're going to look at the difference between rational and irrational numbers. So the first thing we need to do is just kind of define what rational numbers are and what irrational numbers are before we can go down and sort of determine whether they're rational or not. Now this again should be a bit of a review from last year, but since I'm not exactly sure what you were exposed to last year, I just want to make sure you have a solid foundation before we move on. So as a review from yesterday, rational numbers are numbers that can be written as either fractions or decimals. They can be written as either one. So go ahead and fill this out with me on your handout. This will give you something to kind of refer back to as we get into this unit and we're working together. So rational numbers include both terminating, remember that means it ends at some point, terminating and repeating decimals. It includes both. So terminating would mean like 5/10. Decimal 0.5, 5/10. A repeating decimal would be 0.66666 or 0.101010. It can be repeating sections or just single digits. And also rational numbers are the square roots of perfect squares. So that again should be some review from last year. If you aren't sure about perfect squares, you can go back and look at my video for pre-algebra on squares and square roots, which I did with them earlier this week. So irrational numbers are numbers they cannot be written in a fractional form. They are irrational numbers include non-terminating, and non-repeating decimals. So non-terminating and non-repeating decimal. And they are the square roots of non-perfect numbers. Sometimes they might call these numbers that they look like mumbo jumbo. It's just random numbers. It's not any kind of pattern to it at all. So irrational numbers can't be written in a fractional form. They're non-terminating and non-repeating decimals, and they're square roots of non-perfect squares. So it might be like the square root of 60. There are no two numbers, if I square them, that will give me 60 as my answer, so that would be an irrational number. So now what we're going to do, we're just going to kind of quickly go through and look at each one of these examples they give us and classify them as rational or irrational to kind of warm us up into the real number system. So if I look at -12, well, -12, even though it's a negative number, is classified as rational because it's not a non-perfect square, and it can in fact be written as a fraction. If I have the number -12, I can write that as -12 over 1. I can write that as a fraction. So it's a rational number due to the fact that it can be written as a fraction. I know if we look at this, this is the mathematical symbol for pi, and pi mathematically is 3.147. It's just a whole bunch of numbers after the decimal, and none of them repeat. So due to that, we would classify this as an irrational number. And it's due to the fact that it's a non-terminating and non-repeating, non-repeating decimal. It's just nonsense numbers is what we might call it. Decimal. 0.6, 6/10. because there's no line over it and there's no numbers after that. This is a terminating decimal, meaning it stops right after the 10th place. So we would classify that as a rational number. It is a terminating decimal, meaning it stops. Terminating decimal. All right, 7/8. 7/8 is a rational number. We can write it as a fraction. It is written as a fraction. We can convert this into a decimal, and then we can kind of change them back and forth into fractions and decimals. So this is in fact a rational number. The number can be written as a fraction, and it in fact is. All right, if we look at this, we have a decimal here, or and it's 1, 2, 3, 4, 5, 6. This is a very, very, very small number. It's going into like the 100,000th place, and since it's going on to infinity, it's a microscopic number, and nothing here is repeating. So this, because it's a non-terminating, non-repeating decimal, we would classify this as irrational. So it's non-terminating, non-repeating, decimal. So therefore we would qualify it as irrational. All right, here we have 33 hundredths, but this line over the threes indicates to us that 3 is going to keep repeating over and over and over and over again. And anytime we have a number or a block of numbers that repeats, we call that a repeating decimal. And any kind of repeating decimals we have, we classify those as rational numbers. So it's rational because it is a repeating decimal. All right, next we have the square root of 20. So thinking about perfect squares, I know that my first perfect square, if I'm thinking about multiples, is the square root of 16, which is 4. And then the next perfect square that I have is 25, and that's 5. So in this case, 20 is irrational because it's a non-perfect square. There's nothing that can be multiplied by itself to give us 20. So therefore this number is irrational. It's a non-perfect square. Negative 1 and 75 hundredths. Even though it's a negative number, it still is a decimal, and it is terminating. It stops. So therefore this is a rational number because it is a terminating decimal. Here we have a negative symbol and then the square root of 121, and I know from back thinking about my perfect squares that the perfect square of 121, the square root of 121 is 11, so this would be a negative 11 because we have that negative symbol here, but that's a rational number because it's a perfect square. So rational because it's a perfect square. So between qualifying and introducing rational numbers and this kind of review should sort of help you understand the rational and irrational numbers, just kind of get that dust off of our brain from over the summer and not really thinking mathematically about these things. So the next thing we're going to do is move into spiral notebooks, and we are going to do a foldable activity that's going to also help you with classifying numbers as rational versus irrational. So the teacher is going to pass out to everybody a piece of paper, and what we're going to do is go into our notebook. I think you guys have spiral notebooks. If you don't have it today, then I'd like for you to just kind of follow along. And then you can put this in your notebook when you get it out of your lockers. So today what we're going to do is you are going to be getting a sheet that looks like, hang on just a second, let me pull it out here. I just had it in front of me. Here it is. So you're going to be getting a sheet that looks like this. It's dual-sided. So what's going to happen is you're going to cut around the dotted lines, and then when you do that, just like it says, put glue here. You're gonna fold on this line, cut here. You're gonna put glue down on this side, and then when you fold it over and glue it down, this is what it will look like. So as you're gonna glue this down, use a glue stick instead of regular glue. It'll dry faster so that we can write on it right away. And underneath each one of the tabs, we're going to kind of make a little cheat sheet so that in case you don't have those handouts we just did in front of you, this will help you to have some information to recall what irrational versus irrational. So the great thing about this foldable is that it's going to give you some examples so that you kind of have a little bit of a cheat sheet as you're looking at rational versus irrational numbers. So I'm going to give you guys a chance to go ahead and pass out all the supplies. There's scissors, there's glue in the room. Everybody should have a notebook. Open up to the first page of yours. I skipped a page because I thought there might be something that we did before this, but we're not. So go ahead and put this on the first page of your notebook, and when you're done, come back and we'll go over what we're going to put on the tabs. All right, everybody should have glued this down, and now we're going to kind of open up our flaps, and we're going to write down some information that's going to help us remember rational numbers versus irrational numbers. So when I'm looking over here at the side, these are some numbers that we call rational numbers. We see the perfect square, we see whole numbers, we see fractions that are repeating and terminating decimals. We see decimals that terminate, decimals that repeat. We see all kinds of numbers. So what we're going to write in under the rational area, I'll zoom in here, is that rational numbers are numbers that can be written as fractions. Terminating decimals, repeating decimals, and perfect squares are all examples of rational numbers. And all fractions and decimals that either end or have a repeating number pattern, those are classified as rational numbers. So I'm going to go ahead and give you guys some time to write that down. This and your other notes will help you on down the line. So go ahead and pause the video and come back when everybody's done writing. All right, so now that we talked about rational numbers, let's move on down here to irrational numbers. And what I see over here for some examples are not perfect squares. I have pi times a number. Remember, we said pi is like a mathematical number that just repeats, all kinds of random stuff. Again, I see imperfect squares. I see decimals that just... This is indicating that these don't repeat. It's just numbers on and on forever. So let's look at what qualifies as a rational number or irrational number. Irrational numbers are numbers that can't be written as fractions. They are non-terminating decimals, non-repeating decimals, and non-perfect squares. Decimals that never end and have no repeating pattern are also qualified as irrational numbers. And when we're talking about these, we might also call them as mumbo jumbo numbers. They just repeat random numbers, and there's no rhyme or reason. There's no repetition. It's not the same number over and over again. So I'm going to pause this here and have you guys write this in. All right, and then the second activity that we're going to do today is going to involve another cut and paste activity, and you guys are going to finish this one tonight for homework. So we have the notes on rational versus irrational numbers. We talked about our introduction to rational numbers, where we divided numbers into whole numbers, natural numbers, integers, rational numbers, all these various things. So what I want you to do tonight for homework is take all of that information that we have, and you're going to cut out these little tabs, and you're going to glue them in your notebook, and then you're going to look at the choices here and decide which ones go into which pocket. So you're going to get two sheets. You're going to get this sheet that has little pockets, and when you cut them out, you're going to cut out along this really bold line on the outside, and then this little area here is where you're going to glue. You're going to leave this area in the middle with the word, that square, unglued, so that you can stick all the little pieces that are on this sheet in the correct pocket. So your homework tonight is to cut these out, glue them on the next page of your notebook, and then use all the notes we talked about to help you determine which are integers, which are whole numbers, which are natural, irrational, and rational. So that's your homework assignment tonight. So you're going to bring your notebook back tomorrow with all the these little pieces put into the correct pocket, and we will go over that first when you come in tomorrow. Remember that these are due at the beginning of class. If you come without this complete, that's automatic detention tomorrow afternoon. So please make sure you come back with that ready to go, so that we can get jump right into to going over it and keep moving on with our day. I will see you tomorrow.